Hi, I'm Mike Ducharme. I'm the lead suspension design engineer here at Felt Bicycles, and I'm here to tell you about a new suspension technology that we've come out with for 2011. We call it FAST technology. It's Felt Active Stay technology. For 2011, we now have two basic platforms. We have the EqualLink, which we've had for the last 5 years and firmly believe in, fantastic, super efficient system, but we knew that if we were going to design something for World Cup level athletes, that we had to address their needs. Our challenge was create a system that met their goals, their needs, and still satisfied our desire to have an efficient, durable, and easily manufactured system using technologies that we knew we had and then creating some new ones as well. We came up with something that was very clever in the way of having a rear set of stays that acts as a secondary spring, holding the suspension travel basically at sag. Sag meaning that's when the rider's weight is sitting on the bike and holding it at a position where it will be ridden most of the time. In a cross-country race, your weight is biased in such a way that you're getting about 25% sag. Our system is designed to hold the rider at 27, so it's while the bike is still active and moving. That doesn't mean that the bike is not active. It's very supple, very smooth, but the stays are fixed at that angle, basically holding the shock at that position. So there's a little more resistance to going either open or closed in that system from static. When Felt first decided to do a real race bike, we went through a lot of different meetings and discussions about what platform we were going to use. Obviously, we wanted to use EqualLink on that. We built some test prototypes, definitely had some race bikes built, did a lot of racing on those prototypes, and even had some go out to some of our racers. We started with a clean piece of paper and just said, wow, what are we going to do? And went with, let's do it as light and minimal as possible, because that's what those guys want. And then we said, okay, but now how do we make it as efficient as we want it to be? And that's where FAST technology came in. It was kind of a revelation that we saw if we located those fast stays to holding the bike at a certain location within the travel, that it would really hold the bike in a more efficient level and meet the goals for our design team. Whereas looking at the bike and the light weight of it certainly met the goals of the racers. Now when we show them an edict, their first question isn't, well, okay, how heavy is it? Their first question is, wow, okay, when do I get mine? And that was kind of a neat thing. One of the beauties of going into this project was knowing that we had a bike that would have a limited amount of travel. The chassis that we chose was the standard World Cup travel of about 100 millimeters of rear wheel travel. The edict, which uses FAST technology, has exactly that, 100 millimeters. So now we could take that window and say, how do we make that the most efficient travel we can, not using the EqualLink system? So what we did was we came up with our new stays, which are carbon molded in one solid piece, and there is no pivot in the rear dropouts. If you look at on our EqualLink bikes, you'll see that some of them have pivots and some of them also have a flexible carbon stay. What that did was it helped increase durability by eliminating parts in the system. So the rear pivot now didn't exist, just a carbon component that has zero maintenance, zero issues, and we could design the compliance into those stays to be exactly what we wanted it to be. Now we have the stays themselves articulating and holding that suspension at a certain point. Fast active stay technology. What that means is the stays are actually constantly moving within themselves as it's going through its travel. You ask any World Cup level racer and they will tell you their number one goal is to have a light bike. Regardless of what they think the efficiency is, you'll have a hard time convincing them that a heavier bike will make them faster. So our goal there was use the best materials we possibly find. All carbon fiber throughout the entire design, especially in the stays. That allowed us to do our FAST technology, having the stays articulate. And this is exactly what this technology is, only very lightweight and designed to be a multifunction tool. Holds the rear wheel in place, increases efficiency. The pivots themselves, all of the axles and hardware are materials that are chosen exactly for the job. No shortcuts. There's titanium hardware, 6AL4V hardware, and all of the fastening of the bolts. The axles, where they can be, we made them 7075 aluminum, very high strength, very lightweight. We're toying with the idea of using some magnesium as well, but carbon fiber titanium, aluminum, aircraft aluminum, lightweight bearings, DU bushings, titanium stub axles. There's a lot of technology in this bike that brings it to be what it is. And really, with a rear shock, this is a 4.4 pound frame with a real 100 millimeters of rear wheel travel. So to cap off, FAST technology, Felt Active Stay technology, is actually designed to help hold the suspension at a certain location, a location that is what we consider to be the optimal location for while you're racing or riding the bike, which is sag. 25 to 27% is about the recommended range. The stays themselves are perfectly neutral at that 27% range, and from there they want to either extend or compress the suspension, or when the suspension wants to be extended or compressed, those stays resist that, helping hold the suspension at that location regardless of drivetrain loads or bump forces that are coming into the wheels. That also allows us to design the carbon layups so that the compliance can be designed into any direction we want, as well as stiffness, which again, for the amount of stiffness and compliance that we want, we're able to achieve that in a much lighter package.